So today we are going to discuss about multiple things. At first we are going to discuss about the algebraic variable, then we are going to discuss about the random variable, and then we are going to discuss about probability. Then we are going to discuss about discrete random variable, continuous random variable, and probability distribution. And then we are going to discuss about the types of probability distribution, in which we are going to discuss about the discrete probability distribution, and later on we are going to discuss about the probability mass function. Then we are going to discuss about the probability density function, and we are going to discuss about the continuous probability distribution as well. Okay, so at first, if we start with the algebraic variable, what is an algebraic variable? Okay, basically, so suppose x plus 8 equals to 10. Here x plus 8 equals to 10. If I talk, or if I talk on this basis, then this x has a definite value which is equal to 2. So here you can't write anything else except 2 in the place of x. So here a variable like x is a unknown value and we can determine the value. But what is a random variable then? A random variable is a set of all possible values of a random experiment. Suppose if I tell you that x is a variable and x is denoting the probability of suppose x is denoting the probability of getting 3 in a dice roll. So what will be the probability of getting 3 in a dice roll? So the probability will be 1 by 6. We all know that. There are total 6 outcomes and 1 is our favorable outcome, that 3 can come. So x can be 1 by 6 here. Now if we elaborate this example a little bit. If we say that there are 2 dices that are rolled and we are calculating the sums, then that sums can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Minimum the sum can be 2, whether in which both the dices are actually giving 1, and the maximum of the sum can be 12. What will be the probability that x will be 12? That means both of the dices are actually giving us 6. So if we draw the sample space of that, then there will be total 36 outcomes, and out of those 36 outcomes there is only a single case in which we will get 6 in both of the dices. So the probability of x equals to 12 is 1 by 36. Now x can be 1 by 36 if we talk about what is the probability of getting a 12. If we talk about what is the probability of getting 2, in that case also x can be 1 by 36. But in some, if I talk about what is the probability of getting 3, then 3 can be found in 2 ways. The first dice will give us 2 and the second dice will give us 1, and otherwise the first dice will give us 1 and the second dice will give us 2. So in this 2 way we may obtain 3. What is the total number of outcome? That is 36. And what is the favorable outcome? That is only 2, because only 2 combinations are satisfying the sum of 3. Okay, so the probability is 2 by 36 or 1 by 8. So what is the value of x here? The value of x here is 2 by 36 or 1 by 18. So here x is not a specific value. X can be 2, x can be 3, x can be 4, x can be 5. So x can take all these values. X can be 9, x can be 7, x can be 8, x can be 10, 11 or 12. So x can be any of these values. X is basically a set of values. So basically we can't assign any particular value to x. We can assign that x will take some certain values, and we can assign the probability of x as taking a particular value. Suppose x is taking the value of 12. What is the probability of that? Probability of that is 1 by 36. Suppose x is taking the value of 3. What is the probability of that? It is 2 by 36 or 1 by 18. So this type of variable is called random variable. It is a set of all possible values of a random experiment. What is a random experiment? Which is randomly done, like throwing a dice or flipping a coin, any kind of experiment that is done randomly. All the results of that experiment can be shown by x, but what value x will take, that is supposed to be represented by a probability. Just like in this case, x taking the value of 12, what is the probability of that? 1 by 36. X taking the value of 12, what is the probability of that? It is 1 by 36. Here x is not 12 for sure, x can be certain other values. X is a set of all these values of the experiment, 2 3 4 5 6 7 8 9 10 11 and 12. But here when I am talking about that, what is the probability that x is 12, x is taking a certain value or particular value 12, then that probability is 1 by 36. Here random variable is denoted by capital X, and algebraic variable, which we have talked earlier about, is denoted by small x. What is a discrete random variable? A random variable is called discrete if it takes only distinct values like 1, 2, 3, 7, like number of movie tickets. You can't say that the number of movie tickets are half, or 1 by 2, or 1 whole 1 by 2, or 3 by 2. This type of things can't be said about a movie tickets. A movie ticket means it will be in a whole portion. It will be 1 ticket or 2 ticket or 3 ticket. Number of students in class. So can we say that there are 37.5 students in the class? Never, it is not possible. We have to say that there are 40 students or 37 students or 38 students in the class. So the variable, the random variable, that can take only distinct values like 1, 2, 3, 57, 92, distinct values only. Okay, so this type of variable is called discrete random variable, like number of movie tickets, number of students in the class. Now the interesting part comes, that is the continuous random variable. A random variable is called continuous if it can take continuum of values. What is a continuum of values? Suppose I have given you a task to measure the weights of the students in a class, or measure the heights of the students in a class. Now if I talk about the weights of the students in a class, now the weights can be anything. It can be 18.2, it can be 30.5, it can be 45.7, okay, it can be 39.6. So basically the variable is not taking any distinct value, just like the previous case. It is taking continuum of values. It can take any value actually. In between the range, it can take any value. So as it is written here, the value can be anything within a interval or range, like the height can be any number from the range of 2 feet to 8 feet. If I assume that height is in between 2 feet to 8 feet in general. Age can be any number in between 16 to 19, assuming that I am assuming class 10. So if I go to class 10, in class 10 I may find a student who has the age of 16 years 2 months and 5 days. I can find a student who has the age of 17 years 3 months and 2 days. So here I can't say that my variable will take a distinct value. Here my variable will take continuum of values, or it can take any value within the specified range. So this type of random variables in which the variable is taking continuum of values is called continuous random variable. I hope this is clear. Now what is probability? Probability denotes the possibility of outcome of any random event. The meaning of this term is to check the extent to which the event is likely to happen. For example, when you flip the coin in the air, what is the possibility of getting a head? The answer to the question is based on the number of possible outcomes. Here the formula of probability can be defined as favorable outcome divided by total outcome. So basically when I am talking about probability, suppose there is a boy who wants to go to school. Now what is the probability that whether the boy will reach school or not? I mean, whether the boy will actually go to the school in that day or not. So there are two scenarios in this case. There are two outcomes that are possible. The boy will reach the school, or the boy will doesn't leave his home and he will remain in home and he will doesn't go in school. So there are two possible scenarios in this case. Any of this will happen. What is the probability of any of this happening? So if I ask you what is the probability of the boy reaching school, so the answer will be 1 by 2. How? Total outcome is 2, right? So the formula is favorable outcome by total outcome. Total outcome is 2 because there are total 2 outcomes. The boy will reach school or the boy will not reach school. What is the favorable outcome? Favorable outcome is the outcome that is likely to happen, that we are expecting to happen. So suppose if we want to know that what is the probability of the boy reaching school, so in that case our favorable or likely to happen event is the boy reaching school. So that is only 1. So 1 by 2 is the probability. So this is a very simple example of probability. Now if we talk about probability distribution. So probability distribution is a list of all possible outcomes of a random variable along with their corresponding probability values. So basically if we take that we have done a coin test, and what is the probability of getting a head? That is 1 by 2. If we take the probability of tail, that is also 1 by 2. So basically if we take an example of coin tossing and if we calculate the probabilities of getting a head or a tail, then the probability distribution can be defined as followed in the mentioned form. So this table can be said as probability distribution. Okay. So representing the values of probability corresponding to the events is basically known as probability distribution. Now this is probability distribution, but if we have very high number of outcome, right, and high number of corresponding probabilities at the same point of time, then it won't be possible to represent it by a table. So in that case, how can we represent the probability distribution? So we will basically introduce a mathematical function to model the relationship between the outcome and the probability. This mathematical function is known as probability distribution function, which are basically of two types: probability mass function and probability density function. So basically let me tell you again, what is probability distribution? Probability distribution is basically representing all possible outcomes of a random variable and their probabilities in a table. All possible outcomes of a random variable and their corresponding probabilities, if we represent it in a table, then that is probability distribution. But if the number of possible outcomes are very high and the corresponding probabilities are also very high, then it will be very difficult for us to represent it by a table. So that's why we are going to introduce a mathematical function which will give us the relationship between the outcomes and the corresponding probabilities. So basically there are two types of probability distribution function: probability mass function and probability density function. We will discuss about these two functions in the later part. Now at first we will discuss about the types of probability distribution. There are two types of probability distribution. One is discrete probability distribution and another one is continuous probability distribution. So what is discrete probability distribution? A probability distribution in which a random variable x can take only a specific value or only a distinct value, or x is basically a discrete variable. A probability distribution in which x is a discrete variable can be termed as discrete probability distribution. We can also call that probability distribution of the discrete random variable are called discrete probability distribution. It is very easy to understand. Let me give the example, then it will be much more easier. If we throw a dice, you can't tell that if we throw a dice I will get 1.5 or I will get 2.5 or I will get 3.7. It is not possible, right? If we throw a dice we will get 1, 2, 3, 4, 5 or 6. We will not get anything else. Now the discrete random variable can take specified values like 1, 2, 3, 4 or 5 or 6. So this is the classic example of discrete probability distribution. If we represent the probability distribution of the discrete random variable is if we want to represent the probability distribution of a discrete random variable, then we can take the example of dice throwing. Here the probability distribution of the discrete random variable is giving that it can take up any of these 6 values, not anything else. This is the example of discrete probability distribution. If we throw a dice, you will get only any of those values out of these 6 values, right? You won't get anything else. So basically this is the example of discrete probability distribution. Now the question is how to draw the graph of this discrete probability distribution. For that we require a mathematical function that represents the relationship between the outcome of the discrete random variable and their corresponding probabilities. This function is known as probability mass function. And what is probability density function? Probability density function is just like probability mass function, but it represents mathematical relationship between the outcomes and the corresponding probabilities, but it is used for the continuous probability distribution. So what is probability mass function? The mathematical function that describes the probability distribution of a discrete random variable is called probability mass function. So basically we have a mathematical function, and that mathematical function is describing the relationship between the values of the random variable and the probability distribution. Okay, so the probability mass function of a discrete random variable assigns a probability to each possible value of a random variable. It shows the relationship between the outcomes and their corresponding probabilities. For creating the graph of discrete probability distribution, we require the probability mass function. Here, by the help of probability mass function, we are going to draw the graph of discrete probability distribution. Let us write the probability mass function. So suppose there are 4 numbers 0, 1, 2, 3 and 4 in a box. If we want to randomly draw any particular number, so obviously if we want to draw any particular number, then the probability of getting each number is 1 by 4, right? And if we want to draw 5 or 7 or 10 from that particular box, then the probability uh, will be 0, obviously, because there is no 5, 7 or 10 in the box. There are 4 numbers only in the box. This 0 should not be here. Okay, sorry, this 0 should be here, this 4 should not be here. Correct it. I mean, if you are writing it, then don't write this 4. There are only 4 numbers in the box 0, 1, 2 and 3. And if we want to randomly draw any particular number, what is the probability? Obviously the total numbers are 4, total outcome is 4, and the favorable outcome is 1, as we are trying to draw any particular number or each number, any of the each number. So basically the probability is 1 by 4. And but if we want to draw 9 out from this box, then the probability will be 0, because there is no 9 in this box. If we want to draw 3 out of the box, then the probability will be 1 by 4. If we want to draw 2 from the box, then the probability will be 1 by 4. So let us write the probability mass function. If x equals to 0, then function of x is nothing but probability is 1 by 4. If x equals to 1, probability is again 1 by 4. If x equals to 2, probability is again 1 by 4. If x equals to 3, probability is again 1 by 4. Otherwise, if x is not belonging to any of these values, say 1, 2, 3 or 0, then the function of x, that is the probability, is 0. So what is our probability saying? Function of x, which is denoting our probability, it is saying that the value of the probability will be 1 by 4 if our random variable x is belonging to any of those values 0, 1, 2 or 3. Otherwise our value of the probability will be 0. Okay, so that's how we write the probability mass function. In this way the probability mass function is written. Okay, and here our sample set, or here our sample space is 0, 1, 2 and 3, the values. Let's graphically represent the discrete probability distribution. So this is the discrete probability distribution of a dice being thrown. So here we have thrown 2 dice. Okay, so as you can see, if we throw 2 dice and if we are calculating the sums, then what is the probability of getting 2? As I have told you, the probability of getting 2 is only 1 by 36. I have told you it in the earlier part. So here we are representing it by the histogram. Similarly, what is the probability of getting what is the probability of getting 12? That is also 1 by 36, because only in one case where both the dices are showing 6, in that only one case we are getting 12. Okay, so that will also be 1 by 36. What is the probability of getting 3? That is only possible when first dice is showing 1 and second dice is showing 2, or the first dice is showing 2 and second dice is showing 1. Okay, so the probability will be 2 by 36, because the favorable outcomes are 2 and the total outcomes are 36. So by this way we have drawn the graphical interpretation. Now this is, it is written here also. Here we have taken an example of 2 dice being thrown, and as you can see, the probability, and as you can see, the probability of getting 1 is 1 by 36, and the probability of getting 12 is also 1 by 36. The probability of getting 6 is 1 by 36. Probability of getting 6 is 1 by 36. No, it is written wrong here, I feel. The probability of getting 6 is 5 by 36. That should be corrected. Here the x-axis is taking the value of random variables and the y-axis is taking the corresponding probabilities. Obviously the y-axis is showing the probabilities and the x-axis is showing the values of the random variables. Okay, now I will discuss about the reason behind doing this in the later part, but for the current scenario I am going to discuss about the continuous probability distribution. But for the current part, I feel I have cleared the doubts of probability mass function and how to plot the probability mass function graphically. I hope this part is clear now. So now we are heading to continuous probability distribution. A probability distribution in which a random variable is continuous. That is continuous probability distribution, right? It is very easy. If you have to give the definition very much easily, if you have to give the definition very easily, then it is very easy to understand that a probability distribution in which the random variable x only takes random variable x can take any value. X is continuous variable means what? It can take any value, right? So basically a random variable x, if it is taking the continuous, if it is a continuous variable, then that distribution is called continuous probability distribution, as it is showing the probability distribution of a continuous random variable, as continuous variable can take infinite number of values. So if I want to calculate the probability of getting a particular value out of infinite number of value, then that can be written as probability equals to favorable outcome by total outcome. Now here this is interesting, very interesting. It is that in the previous case the total outcome was given to us, that in case of dice throw the total outcome were 6, 0 1 2 3 no 0, sorry, yes, no 0, 1 2 3 4 5 and 6. These were the 6 total outcomes. But if I tell you that there is a classroom and what is the probability of getting a boy of weight equals to 50 kilo or 50.2 kilo. Now the formula is same, you have to just find out all the weights, right? Now here the weight is a continuous variable, the formula is same, it is favorable outcome by total outcome. But here the total outcome is not known to you, because the total outcome can be anything. The weights can be any number, it can be 15.1, it can be 15.125, it can be 52.1, it can be 53.7, it can be 59.2. so you can't define it by any definite number so that you can count it. It can be infinite number of numbers, it can be infinite. Okay, so basically what we are talking about here, that the total outcome is infinite and any number divided by infinite is 0. So in case of continuous probability distribution, if you want to calculate the probability, it will be 0. So that's why in case of continuous probability distribution, we can't calculate the probability of a particular point. We will estimate the probability of getting a value within the particular range or interval. For estimating the probability density, we are going to take the help of probability density function, which is also known as PDF, which is just like the probability mass function, but it is just going to give us in case of the continuous probability distribution. So probability density function is used to define the random variables probability coming within a distinct range of values, as opposed to taking any one value. So in probability mass function we are taking any specific value. In probability density function we are not taking any specific value, we are taking a range. So this is how mathematically we represent it. Probability of x lying in the range of a and b, it is mathematically represented as integration of integration a b function of x dx, and integration a to b function of x dx. So that's how we write it, probability. That's how PDF is written. So this is the form of PDF in which you can write the PDF. Now probability density function, how to graph it, I will discuss it, but the graphical representation will be in the next part. We will continue about it.